Here we're going to look at the radius and interval of convergence. And so we're going to look at basically, there's something special with power series, which includes Taylor series, includes Maclaurin series. There's something special about how those series converge. So a power series, we'll have to do a little bit of review here. Recall that for a power series, it takes the form of, let me just make sure I have it written the same way that you would have seen it in your notes. The sum from n equals 0 to some, arbitrary constant of c, the coefficient of n, so some coefficient, times x minus a to the n. And this will give us c0, x minus a to the 0, plus c1, x minus a to the 1, plus c2, x minus a to the 2, etc. And that's where we get the Taylor series and Maclaurin series. Is just how do we get these specific constants. And so remember that we say the series is centered at a because we have this x minus a term. And so if it's centered at a, we know that the series converges when x equals a. And this is because if you look back to it, you've got the term x minus a to the n times cn as your general term. So if you plug in x equals a, this expression goes to 0, and no matter what you're adding, you're always adding 0 because cn is going to be some constant, and you have 0 times a constant, that's 0, so you add an infinite number of zeros, it's going to converge. And it may, in fact, converge for all x values, but we don't know yet. We'd have to check that. So it definitely converges at x equals a, and it may converge for all of x values. If it doesn't converge for all of x values, it will converge for some values around x equals a. So a plus a little bit, a minus a little bit will also converge. It's just the question of how far do we get away from a before it stops converging. So let's summarize that. Given a real number r, if x minus a is less than r, then the series converges. So remember, it always converges at x equals a, but it will also converge for some small region right around a. If x minus a is greater than r, then the series definitely diverges for this case. And if x minus a equals r, the series may converge or diverge. So basically what we're saying here is we know it converges at a. We also know it converges close to a because if you go back here, x minus a, if x is very, very close to a, like infinitely close, then this is still going to be functionally 0. So unless c of n is absolutely gigantic, this is basically adding a bunch of really, really, really tiny numbers, and so it will likely converge. So there is some radius, which is r, that tells us where it converges. So r is known as the radius of convergence. And the interval of convergence is x, sorry, not x, it should be a minus r to a plus r. And then you'll have to decide if it's less than or equal to in both these cases by finding out if it converges at these points. So you have to actually use another series test to determine this. This is one that we'll do an example, and that should kind of help you see how this applies or comes into practice. So for example, what's the radius and interval of convergence for the series x plus 4 to the n over n times 4 to the n? So anytime I see n's in my exponents, or I see variables in my exponents, I'm thinking ratio test. But let's run a quick check here just to do an easy nth term test. So when n equals infinity, well, we don't know what's going to happen because x could be any number. So we have to use the ratio test here. So we're going to do x plus 4 to the n plus 1 over n plus 1 times 4 to the n plus 1. Absolute value, limit as n approaches infinity, times, and then we're going to flip this to get the reciprocal, because technically, remember, the ratio test is the limit as n approaches infinity of a n plus 1 over a n. But I can also write this as a n plus 1 times 1 over a n, which when we have fractions like this is convenient because then I can just do the reciprocal. So I have n times 4 to the n over x plus 4 to the n. And this needs to be less than 1. So let's check this out. So 4 to the n plus 1 and 4 to the n will cancel, kind of, and x plus 4 to the n plus 1 and x plus 4 to the n will have some things that cancel. So limit as n approaches infinity of x plus 4 to the n plus 1. There's one more of these x plus 4s than these. So we get x plus 4 just to the first. There's one more 4 on the bottom than there is on the top, so it's going to be divided by 4. And then we're also going to have n over n plus 1. Well, when the limit as this goes to infinity, that basically ends up getting rid of this term, making it go to 1. So we have that the absolute value of x plus 4 over 4 has to be less than 1. So if we want to write that out, we know that negative 1 has to be less than x plus 4 over 4 is less than 1. So whenever we have something like this, remember, this means plus or minus. Well, if I want to represent the plus, I don't need to change anything, but if I want to make this minus, I need to multiply both sides by negative 1, and when I multiply by negative 1, that flips the sign here, and that's why we get this expression here. So that means that we need to get x needs to be anything where x is less than 1. So that means x needs to be any negative number between 0 and 4. Well, let's do this out a little more rigorously. We can multiply both sides by 4. And then I can subtract 4 from both sides. So negative 8 is less than x is less than 0. So if x is anywhere between negative 8 and 0, we know it has to converge. So what is our radius? Well, it's half that distance because it's going to be centered at x equals negative 4, which we actually already knew from here that it was centered at x equals negative 4 because this is x minus a is 4, or negative 4. So our radius is equal to 4. Again, because it's half the distance of my interval. Now we need to find out if these are less than or equal or just less than expressions. So let's plug in our x equals negative 8, evaluate it, and plug in x equals negative 0. So if x equals negative 8, we get the expression of negative 4 to the n over 4 to the n times n, which means we get negative 1 over n. And this is, we see it's an alternating series. yeah, we see that this is an alternating series, and therefore it's decreasing, and it is continuous, so this converges. If x is equal to 4, or if x is equal to 0, then we get 4 to the n over 4n times n, and that's equal to 1 over n, and this diverges because it's the harmonic series, or it diverges by the p-test, the p-series test. So what that means for our interval is -8 is less than or equal to x is less than 0. So for all of these x values, the series converges. If it's -8, all the way up to, but not including, 0. This is the way that all of these will work, is you'll basically use for the AP test, you use the ratio test, set less than 1, you'll do some work to find out what the x values can range between, you'll plug in the two endpoints. Typically, but not always, one endpoint will be an alternating series test that converges, and typically the other will be a harmonic series that diverges, just because that's the simple kind of prototype way to have it be interesting and have one side converge, one side diverge. It's really easy to come up with an infinite number of permutations of this that all kind of work similar. There are other ones that show up, but this is by far just a really standard example, just with, slightly different numbers that can show up.